What would you think if I told you that warp propulsion is no longer pure science fiction? Can you imagine that we will soon have spaceships traveling at the speed of light or even faster? Scientists have even discovered a completely new way to travel 10 times faster than the speed of light. You'll be amazed at the fantastic changes this will bring in the future. Faster than sound, faster than light, Concorde, the supersonic passenger plane that took just 3.5 hours to fly from Paris to New York, was a milestone in aircraft development. Concorde has long been history. Today, only fighter jets fly at supersonic speeds. We humans have long since reached the next threshold. On our way into space, we need spaceships that are faster than light. Otherwise, the enormous distances in the cosmos cannot be bridged, and we would need millennia just to reach the next star system. For a long time, physics did not seem to allow humans or anything else made of matter to travel as fast as light. What was the reason for that? Well, it's simple. Einstein stated in his equations of general and special relativity that nothing in space can travel faster than light. Matter can't travel even close to that speed because, in that case, equations of dynamics and energy requirements no longer applied. Scientists truly had to think hard to solve this puzzle. Now, there may be a way to bend time and space to our will and create a spaceship that can travel faster than light. If you love science fiction space movies, you already know the warp drive. From real life, the spaceship accelerates for a moment, then only a bright light can be seen, and matter disappears in time and space to reappear at any place in the cosmos. Enormous distances are covered in a very short time, and travel to the farthest reaches of the cosmos would be real. Although the concept was popularized as pure entertainment by authors such as John W. Campbell and legendary Enterprise creator Gene Roddenberry, science picked up on the concept in the 1990s, bypassing Einstein with a trick. Einstein's theory of special relativity states that energy and mass are interchangeable, and travel at the speed of light is impossible for material objects with a non-zero rest mass. This means that objects traveling at the speed of light require an infinite amount of kinetic energy to reach that speed. Theoretically, the dilemma can be solved by folding or warping space around the object. Warp means to distort or to bend. Instead of creating thrust with energy, the force is invested in distorting the space. A kind of fold is created through which the spacecraft then slips with relatively little effort. Einstein's theories, which have become the scientific foundations of cosmology and physics, were unaffected by this concept. Two problems remained: generating the energy to fold space and technical feasibility. In 1994, Mexican physicist Miguel Alcubierre solved the problem, at least at the theoretical level. He used Einstein's theory of general relativity during his doctoral studies at the University of Wales to develop a framework within the limits of the laws of physics that would allow faster-than-light travel. On the practical side, relativity states that objects become heavier and heavier as they travel faster and faster. It's logical: the heavier these objects become, the more difficult it becomes to maintain acceleration or even increase it to the point where a spacecraft reaches the speed of light. Only particles that have virtually no mass can travel at these enormous speeds. Photons are among them. Miguel Alcubierre developed a drive which was named after him. The principle is simple and easy to understand even for laymen: a purely local expansion of the spacetime continuum behind the spacecraft and a contraction in front of it allows motion that is perceived as faster than light by observers outside the distorted region. The occupants in the distortion, on the other hand, would perceive nothing, or let's say, not much. Perhaps they would perceive the famous tail of light, see the stars whizzing by, or notice a slight vibration. Within a few moments, a warp spaceship could cover immense distances, truly as if in flight, or otherwise said, in faster-than-light flight. The Alcubierre drive is virtually capable of expending an enormous amount of energy to contract and twist the space-time continuum in front of it, creating a bubble that simultaneously folds space. This bubble is a physical inertial system, which is why the occupants would not feel any actual acceleration. However, the rules of physics would be obeyed inside the bubble. Inside and outside, everything would conform, and nevertheless, matter could move in this way faster than light through space. Only not with thrust and speed as we know it from cars, airplanes, or space probes, but by an ingenious trick. The universe offers unknown possibilities. One mistake we humans like to make is to think of the universe as one space. According to relativity, however, space-time is a flat sheet that is distorted by any object with mass. The space effect, as we know it, comes from the influence of mass, and it is this distortion of the space-time continuum, found at all corners of the universe, that we experience as gravity. Yes, even you are distorting space-time a little bit right now as you are sitting there in front of your computer or smartphone, and you are causing gravity. In this context, of course, the exciting question arises whether a human being could also push through a time fold by consciously contracting the space in front of him and come out somewhere else in space. Theoretically, this is possible. Practically, however, you would have to produce a whole quantity of force in order to distort the space by a multiple more than this happens only by your weight. The Alcubierre drive creates the bubble which is necessary to evade the laws of physics in the outside. Inside, with a propellant, this is exactly where we still have a bit of a problem. Because whether we use diesel, gasoline, hydrogen, or methane, we currently can't muster the power. In fact, we would need energy equivalent to the mass of Jupiter to muster the energy with means known so far. In the meantime, however, a solution has been found for this problem: negative matter. This exotic substance, which has a negative mass or energy density in theory, is supposed to be the long-sought answer. However, if we look a little more exactly, then we must find that here again, a tiny little problem appears. Negative matter is not only hard to imagine but also undiscovered so far. Its existence is suspected, but it is not proven. So how to construct a drive with something that may not even exist? And even if we could detect this form of matter, the question is, how could we collect or create enough of it to power a spaceship? Where there's a problem, there's a solution. Researchers don't rest easy when it comes to warp drive, because we need it, there's no question about it. Before we turn to the latest and most ingenious idea of a practically absolutely feasible warp drive, let's take another look at where we humans stand technically right now. Hold on tight, because now it could become painful for all who dream of faster-than-light travel. Our fastest spaceship's speed of light is a universal physical constant that is approximately 300,000 kilometers per second. The fictional Enterprise could carry its heroes through space and to new adventures at maximum warp speed, 9,000 times faster than the speed of light. Currently, our space probes are the fastest spacecraft we have. Probes are quite small and light, nevertheless, they also need an immense amount of thrust to reach destinations such as Jupiter, Saturn, or Venus. The Juno probe, which orbited Jupiter from 1995 to 2003, traveled through space at a top speed of 74 kilometers per second, which is just 0.2 times the speed of light. Voyager 1 took nearly 35 years to leave the solar system and is now more than 21 billion kilometers from Earth. The fastest spacecraft ever built by humans is the Parker Solar Probe, which reached up to 191 kilometers per second near the Sun. With these numbers, it's probably already clear to you that we humans do not make it very far with the technologies in the cosmos. For us, even small distances are great challenges. We could say in cosmic scales that we can just put our foot in front of the front door. Probes that scientists send into space usually use sophisticated acceleration maneuvers on the gravitational fields of planets to make any progress at all with a reasonable expenditure of energy. Some probes first orbit the Earth twice, then Venus, or they